Good morning to all of you. In previous session, we had discussed about the Z transform and the analysis of LTI system, and we have solved some examples. We have already identified the ROC for the obtained Z transform. In today's session, we'll be going through one more example. Okay. So here again, you have to determine the Z transform of the given discrete time signal x of n. X of n is given as 1 by 2 to the power n into u of n. Okay. So we'll try to identify the ROC of the obtained Z transform, and we'll try to plot the ROC. Okay. So again, the given discrete time signal x of n is equals to 1 by 2 raised to the power n u of n. Okay. The Z transform of x of n is given by capital X of Z is equals to summation n is equals to minus infinity to infinity x of n into z to the power minus n. In place of x of n, you can substitute the given signal value, okay, that is 1 by 2 raised to the power n u of n into, in place of x of n, I have substituted this value, right, into z to the power minus n. Right. I will rewrite this last equation here. So x of z is equals to what we have, n is equals to minus infinity to infinity, is that 1 by 2 raised to the power n into u of n, 1 by 2 raised to the power n into u of n into z to the power minus n. And we know that this u of n is the unit step sequence, and its value is 1 for n greater than or equals to 0, and it is 0 otherwise. Okay. Or you can say for n less than 0, that is means for negative values of n, u of n is 0. So you can eliminate negative values from this summation. Instead of starting from minus infinity to infinity, you can start it from 0 to infinity. That means you have eliminated values of n from minus infinity to minus 1. So the modified limit, I can write it as what, summation n is equals to 0 to infinity, right? All negative values of n has been eliminated from the summation limit. So again, 1 by 2 raised to the power n, and this u of n will be 1 for these remaining values. Okay, for n is equals to 0 and onwards, that is for n greater than or equals to 0, the value of u of n is 1. So for these values, the u of n is 1, so I can eliminate u of n also, or I can substitute the value of u of n as 1 here, right? So it will be simply 1 by 2 raised to the power n into z to the power minus n, right? Again, I can rewrite it as x of z is equals to summation n is equals to 0 to infinity 1 by 2 z inverse raised to the whole raised to the power n, right? So whatever equation that we got here, okay, so it is in one of the geometric series form. It is an infinite geometric series, right? So it has the form, what is that, n is equals to 0 to infinity a to the power n, right? So if you substitute values of n here, so it will be 1 plus a square plus and so on. Okay, so it is an infinite series, right, where the limits are from 0 to infinity. And as per mathematical formation, so you can reduce this infinite geometric series as 1 upon 1 minus a. Okay, provided that mod a should be less than 1, right? So you can simply rewrite this geometric series in this simplified form as 1 upon 1 minus a, but provided that mod a should be less than 1, right? So this Z transform as per this geometric series can be written as, because in place of A there is value 1 by 2 Z inverse, so we can simply write it as x of z is equals to 1 upon 1 minus 1 by 2 z inverse. Okay, if it is that mod 1 by 2 z inverse is less than 1, right? So that is the required z transform, 1 upon 1 minus 1 by 2 z inverse. Okay, so we could this z transform as 1 upon 1 minus 1 by 2 z inverse, right? And to get its ROC, we have this condition, that is 1 by 2 z inverse less than 2, right? 1 by 2 z inverse mod of 1 by 2 z inverse less than 1. Okay, this is the condition. So as per this condition, if you transfer this z inverse on right hand side, so it will be simply z. Okay, because it will be 1 upon z inverse, right? And if you take that z inverse in numerator, so it will be z, right? So it will be 1 by mod 1 by 2 less than z, so it will be simply, you can say that mod z greater than 1 by 2, right? So this will be its what ROC. The values of z should be greater than 1 by 2. If you are substituting value of z is equals to 1 by 2 in this case, so what will happen? So it will be 1 by 2 multiplied by 1 upon 1 by 2. So that 1 by 2 1 by 2 will get cancelled, so it will be 1. So 1 minus 1 will be 0. So it will be 1 by 0, and 1 by 0 will be infinity. Okay, so therefore z is equals to 1 by 2 will not be included in the ROC of the given transform. Okay, so the ROC will be the values greater than 1 by 2 simply. So here we can plot this ROC. So how to plot this ROC? So you can draw x-axis and y-axis, right? So on this x-axis you can indicate, as we know that z is the complex variable, so you can indicate the real values of z on x-axis and the imaginary values on y-axis, right? And to plot this ROC, you will draw a circle, okay, with radius 1 by 2. Okay, so these are the values of 1 by 2, right? So basically it should be a proper circle, right? With center here. So we have taken the radius of this circle as 1 by 2, and ROC is greater than 1 by 2, the values of z, because all these are the values of z which are represented in this plane, okay, that is in z plane, right? But as the ROC is greater than 1 by 2, so the ROC will be the exterior part of this circle. Okay, circle with radius 1 by 2, right? So this is nothing but the ROC. Okay, so this is how you will be plotting the ROC, okay, of the given transform, right? So this is how you are identifying this head transform. We have seen one uh, infinite geometric series here. Okay, how this can be represented in simplified form, that we have seen here. We identified the z transform of the given discrete time signal 1 by 2 raised to power n into u of n, and by utilizing the condition on that geometric series, okay, we identified the value of ROC for the given transform, and by using that ROC we have plotted that ROC, okay, by using this xy plane, right? So in next session, when this ROC basically is exterior of a circle, okay, so when it is exterior of circle, right? So most of the time the signal is called as a causal signal. We have seen this causal signal definition in the previous sessions, right? So this is called as what? Causal signal, or it is also called as what? Right sided signal, right? When the ROC is exterior of circle, right? So in next session we'll be discussing one more example, okay? uh, so we'll try to again plot ROC in that example, as well as we'll try to identify different conditions of ROC, okay, for the set transforms. Okay, that those topics we'll be discussing in next session. Okay, so thank you for joining this session.